Okay, guys. So now let us check how is your sketch. It is closed, okay, and everything is fine. So we can use pad operation.
So,
Yes, please.
what should we do when the line is of white color? Since I'm not getting it whole green. The baseline is of white, sir. White color.
Sorry, can you repeat?
The drawing which I'm drawing, sir.
Ah,
The baseline is of white color, sir. It did not turn green, sir. Why? After constructing, sir. After constructing, the line is of white color, sir. It should turn green, right?
now everything is green, right?
So in my diagram, I'm saying.
Uh, when it is, was it white?
Yeah, it is white, sir, now.
Mm, sorry, I'm confused. Not clear with your question. Initially it was white. You mean to say?
Yes, I'm following you, sir. But the baseline on which I'm drawing is of white color, means, what can be the reason I'm asking, sir?
So let me
Sir,
just.
he is talking about his drawing, not yours, sir. He's talking about his own drawing.
Oh, this drawing. Ah, okay, this drawing.
The
His drawing,
70.
not this. His Sharik has drawn something, and in his drawing, something has turned into white. That's what he want to say.
Acha, acha, acha. Your sketch. You mean to say?
Yeah, my drawing, sir.
Ah, okay, okay, okay. No
That
problem.
70 mm diagram is of white color, sir.
Ah,
70 mm
okay.
line, baseline.
70 mm line is in white color.
Yeah.
So have you constrained it? That is important, right? Have you defined it?
And that's what I'm asking, sir. How should we do it?
See, so one thing is, if you have a line, just check how many ways we need to define it. Okay. So for example, first thing is you need to, when you are drawing a line, make it horizontal completely. How you make sure it is? If it is in the blue color, then it is horizontal. Okay. Just click OK. Then how many ways you need to constrain it to make it green, that you have to see. Okay. One thing is how many directions it can move, that you can see. This is one direction, okay, and this is another direction. Okay. How to arrest in this direction? By giving a dimension from axis to this, you can arrest this direction. So the vertical direction is arrested now. Okay. Now this is green, isn't it? And one more thing what we have to arrest is the length of this. Length of this also should be constrained. Okay. That also should be constrained. Dot unity give, then it will be completely arrested. That means the length, now what is the length of this? It is around 175. So these endpoints will be fixed at the same location. They are not allowed to move away from this location. Okay. From the 75 mm of this. Okay. Now this line is completely constrained. Got it? If it is
Yes, sir, got it, sir.
yeah. So
Thank you,
you
sir.
check in out of this in these areas where you missed it. Okay, whether this
Yeah, the
horizontal.
vertical construction constraint was missing, sir.
Ah, yeah.
Vertically.
Just give
Now it's
that.
green, sir. Okay.
You'll be done. Okay.
Thank you, sir.
Good. Good. Thank you. Okay, guys. Now we are going out of this, exiting this workbench. Okay. We are out of this, and now what is required? Where are we? First, we are at the center. That means we are here. We are here. So what is the dimension we need to give? So we have two limits because we need to use two limits because we are at the center, right? Our plane is here. So what is, we have 42 mm is the width of this part. Okay, so if this 42 mm, then we have to give 21, second length 21, because we are at the center of this part. Got it? Our axis should be at the center, isn't it? Got it, guys? How we consider this? If you don't use this second limit, then all the thickness will be added in one direction only. Okay, maybe in one direction you have to give, but we have to distribute it in both the directions because we have considered the axis system at the center. That's the reason we have to give. We are here, so this thickness should be distributed rearwards and this remaining forward. So that is what we did now. Done. Let me save it. Again, we should not lose the data today. Last time we lost it. Save it outside today. This is R25. Okay, guys. So till now clear. So we are done with this complete profile. Okay. So from front view, what you see here, from here, what you see, the same thing you see here, isn't it? This is our front view, and this is our front view here. Just have a look. Okay. Now, what are the things remaining? How to achieve this? 21. Let's see how to achieve it. Let's try to achieve it in simple way. If you're not getting it, then we'll go for. So, what is your plan to achieve this thing? In which direction we have to do that? Now, front view is done. Now we have to go for side view, right? This is the side view. From side view, you have to achieve this. So, which side view? Let us see. Back view, left side view. Let's see left side view. This is left side view. Okay. Okay. Let us see from right side view. This is right side view. Okay. This is our right side view. That means we are looking from this direction. In this direction, this hole can be achieved. Okay. Let us simply get into this and get this hole done. I want my horizontal, this is vertical, this is horizontal. Okay. Let's swap it and let's make it right side so that I can have same orientation. Okay. Now I need something here of diameter. One side. And what is the, this is 20 mm. Okay. 20 mm. Great. So this will be done here, say up to next. Okay. It because we are at the center, they not reverse side. We're at the center. Okay, because we are at the center. That's the reason we use these options. What we did, we selected, because from here both sides material should be removed. Okay, so both sides material is removed. Any doubt in this, guys? No doubt, right? Okay. Now finally, not finally, we have two more holes to achieve. Okay, so how to get these two holes now? And finally we'll see how to get this, how to get these two holes now. Which is the view we need to consider for achieving these two?
Top views.
Guys, any answer?
Top views.
Top view. Okay, let's consider top view. Which is the top view here? This is the top view. Okay, so as per the rule, we have to create one plane here. How to directly also we can do that. Okay, but the best practice is create a one plane here and then go ahead. That's good for you. Okay, that is the plane. Okay, so I got the plane. Now on this surface, from here to here, how much is the? Just check the distance between this surface as well as this surface. Okay, it's 21. Okay, so click on the plane and click on the parallel plane which is parallel to this. So XY is the parallel plane for this one. Okay, and the distance is 21 mm. 21 mm. Review reverse direction. So this is sitting on this surface. Okay, so select this and then swap it. And you swap it. Now this is vertical. Now say vertical. Done. Okay, so I want something here, a hole. What is the die of this hole? 12 mm. Okay, and what is the location of the hole? This is 12 mm. What is the 21 mm from this surface? Okay, let us say 21 mm. For that, if you want to refer this, what is the best practice? Just extract it, isolate it. Okay, and then only this one is required. Are you going to refer any other? This side 24 mm. That means from here 24 mm, from here it is 21 mm. So let's fix it. Auto search. Okay, auto search and make it constructive element and then say fix. Okay, it should be constrained by giving all the dimensions, okay, because it's just for this thing, a reference. That's the reason I have just constrained it, okay. Maybe this said it is already in the center, so we have to show the dimension even if it is this is 21, I need to say 21 from this, 24 from this edge, from this edge. That means this is not center. Maybe this is the center. Let's see where it is got stuck up. From where it is got stuck up. 2.86. It's a solid line, and we want to have a 12 mm dia here. This is 12 mm dia. Okay, and from this edge to the center, it is from this edge. That means this edge to center, it is 21. Okay, and now from this edge, that is this edge to here, other edge is this one. How much is this? 24. 24. Okay. Okay, yes. So we are done with the dimensioning of this, and these are symmetrical holes. If you see, okay. So in this drawing, it is not mentioned clearly, but in the previous drawing, you would have seen that only dimensioning is done. Okay, this 12 mm is shown to one hole, and they show it like two two times pi 12. That means 2 times dia 12. That means if you have two holes here of the same size, then you have to consider the dia for both the holes. Okay. Okay. Now from this information, we understand that this is a symmetrical part. So let's consider this mirror. Just click on this. Okay. So both holes are created. So you don't need to, if mirror option is used, then no need to dimension it or constrain it again, because it's already done, and the mirror constraint will be taking care of all the freedom of this. It will arrest all the freedom, and the profile will be okay. Okay, because it is a mirrored, it is mirrored from this one. Okay, let's check what is happening here. This is fine. Okay, both both the profiles are closed, and we are ready to go. Good to go for the next level. What is the next step? Our next step is creating holes. Okay, so up to next, simple. Okay, I've selected this, and I said okay, and these holes are done. Let me save it. Okay, so all these things are done. The only thing is we need to achieve this profile. Okay, how to achieve that? So again, we can either achieve it from this direction or from the left hand direction, right? So how to achieve it? Let's have a look at it. This is given 21 there. So if there are no roots, then we can try with this fillet also. Okay, let's try with fillet. Okay, Okay. This is 21. This is 21. Okay. This is not fillet actually. Okay. But we also can achieve it in this way, in very simple way. Okay. So if they are okay, if your customer is okay to achieve like this, if this process is okay, you can go ahead and just do it. Okay. Or else what you have to do, or else you need to select this face again, and you have to remove this material. How to remove that? I'll show you. Okay. So this is one simple method to achieve that such kind of things with the fillet. Okay. If they don't agree with the fillet, they say no, the material should be removed with the pocket operation only. We have this pocket operation, right? So the material only should be removed with the pocket operation. Then what we have to do? We again go back, select it, swap. Where is the vertical? Okay, horizontal here. So now simple. This profile you have to create. Okay. This profile you have to create, and we have to just remove the things. Okay. What is this? 21, radius 21. Radius, that is 21. Simply bring it to one side. Something wrong here. Okay. Let's do it. This must be coincided with the center of this. Okay, done. Now we have to remove this material. How to remove that? We need a horizontal line here. Take a horizontal line. And now this. Okay. You can simply delete this half portion. Now we want only this half portion, and then we have to complete this profile. Take this and simply, so we don't need any control over this profile. We don't have any particular dimensions, so we just need to close this profile. So that's the reason. Simply take this, make this horizontal, again a vertical line. Okay, and let's click on this, and this is done. This is not required. Come and just click on this. Okay, this is closed. And now what should be deleted? We don't want profile in between, so let's delete it. This. Okay, it's completely deleted. Okay, so now simply just make it okay. This is one side. also this side it should be coincide. So just give dimensions and make it constraint. Okay, this and this, done, this and here, done. Okay, how is the profile? Closed. Okay, let's come out. Now I need to remove this material. Okay, up to next. This is also same case. Say up to next. Okay, now what it is saying, this edge fillet what we used to achieve this shape. Actually, we use this edge filler to achieve this shape, but now the material is not available. To create this edge fillet, what we selected, the corners of this pad, actually corners of this we have selected. Okay, so because as the corners are already removed, material is removed from there, that's the reason this will show error. That means there is no edges. What to do with this fillet? So simply delete it. We are done. Okay, so this is our ISO. Anything else is left over? Any other features are left over? No, all the features are done. Okay, okay guys, have a look at this. Just have a look and let me know if you have any questions on this. Just remember the process what we followed. Okay, right from the beginning. What is the process we followed? Why we have considered this view, this origin? Okay, many things we discussed. Let me know if you have any questions at any point of this while doing it. If you have any questions on other questions on this. All good, guys. Okay, if this part is clear, okay, please practice it at home and let me know if you have any issues with this, if you face any problems. Okay, so how we are considering the plane, there are so many simple methods to manufacture, to model it. Okay, we can follow very simple method. We don't need to consider origin there at the center of that hole. Okay, we are following some theory. Okay, we as per the uh, manufacturing process or as per the GD&T, okay, tolerancing process, and as per the other manufacturing different process, like you dimension it, okay, or you, if you want to machine it, so how to adjust the degrees of freedom. Okay, every part will have 6 degrees of freedom. Okay, so all these 6 degrees of freedom should be arrested. So we are following the rules of those arresting 6 degrees of freedom as per the methodology. That's the reason even the part is very simple. It looks modeling looks a little difficult for us because we ourselves giving our difficult target, we can say. So instead of taking this axis here, if you take it here, somewhere here, on this face, you can do that also. Okay, but as per the process, to understand the other methods which are associated with this in the manufacturing or how we consider the part. So to understand those things, where I'm trying to explain you those things. That's the reason. Even simple parts, these are very simple parts. If you take access here, simply you can just do it. You don't need to and add thickness from both sides. We are using options like thickness adding from both sides, right? For example, we created this pad rib also. Okay, so how we did it? Again, we added thickness from both sides. Reason being, we consider this origin at the center of this. That's the reason. Okay, if you consider it here, simply you can with single profile you can just model it. Okay, that's not going to. If you learn it in some, I should not say that, but if you only learn Catia without any theory, okay, without any like manufacturing a view process in mind, or only software, if you learn, then you're going to learn in that way. Okay, if you have some idea on the manufacturing process or the mechanical things, okay, not only software thing, the mechanical engineering things, if they are involved in this, like how to control the phase of this, okay, what is the tolerance, how we are going to decide the tolerance for this, okay, so what phase will be important, what will be the functionality. So those are the things one designer should think of. If you just create a 3D model and just create a drawing, then you are just a CAD. You are a CAD guy. Okay. Computer aided designing. That means only input you'll receive, you just do something and dump it. That is CAD guy. Okay. If you want to become a designer, then you have to learn more than this. Okay. More than this. So you need to learn manufacturing processes. Okay. If you look at a part, then you should be in a position to say that this part is manufactured using this process. Okay, and how many manufacturing process we can uh, use or make use of, and which is the cost effective one. Okay, all this information you should have as a designer. That is designer. Only CAD means only CAD guy. You are just a CAD guy. There are differences in that. Okay? So you want to become a just CAD engineer, or you want to become a design engineer. Okay, designing in the sense innovation. So you need to have many things in your mind. You need to have knowledge in your mind. Okay, CAD CAD engineer only just learn CATIA and just go ahead. You have a lot of jobs in CAD field also. Okay, so to become because you people are just fresh minds, so right from now try to learn things in that direction. Okay, so that's the very uh, uh, we can say steps towards a very bright future. Okay, you need to uh, think about the failure of the path. Okay, the load cases, how many load cases, where the load is coming, and where we can say effectively acting on this path. We need to think about that. Okay, right now we don't have any information, but these are the basic things, basic areas where you need to do research and get knowledge. Okay, we have advanced courses, and Maybe going forward, I'll be in touch with you and I'll explain you. But that's the whole scenario of this. Okay. Okay, guys. So what happened to the previous part? That was the construction of that sketch was a little difficult. Actually, it was not difficult, but for you people, it was for the first time. That's the reason it looked like difficult, but it's not difficult. Okay. So was that okay with you guys? So you want me to show that also? If yes, I'll show you. Okay, that also.
Sir,
Yeah.
sir, can you show the last step again, sir? How to make it the curve circles?
Last part you mean to say, right?
Yes, sir.
So what I'll do, the that part was not saved actually
No, no, sir. In this drawing only, sir.
in
In
this
this
drawing.
drawing, sir, the last steps are the making it a curve, sir.
Just a moment, just a moment. You mean to say the last step? You mean to say
Yeah, sir. Can you just repeat it?
this one?
Yes, sir.
Okay. See, if you want to remove material like this, never close the profile closely like this. Okay. See which area we need to control. We need to have control over this area. Okay, and we have control over that. Okay, till here we need to achieve this shape. So this we have control over this. We need to have control over this. Okay, so we have created this. After that, this material should be removed, both sides. Okay, so in this case, after completing this profile, so you want me to again create this profile?
Yeah, yeah, sir.
What is the 20 21, right? Okay, let me just delete it. Okay, auto search. Okay. So this is our side view, nothing but side view. Okay, no question on this, right? No doubt on this. So we are in the side view. Okay, right side view. Now what we want, just have a look at here. So right now our material is like this. Okay, completely like this. So that should be removed. That means only this much circle we need to maintain. And what is the radius of that? 21. Okay, let's go here and first create that profile. Okay, simply create that profile. Radius is 21. Okay, center. Okay, coincide with the center. Now so this we are interested in this area. This area should be protected, and this area, this material should be removed. This and this. Okay, so how to remove that? From here to here. Okay, so that's the reason we take a horizontal line here. Okay, and extend this line. How you construct it, it's up to you. Okay, there are so many ways to construct. You can get idea, and maybe you can construct it much much simpler way also. Okay, take this. Simply, okay, up to here. This is closed. Also, yeah. Okay. So now this material, we are interested in this material. This material should be removed. That means this material should be inside the profile. Okay. Even if you go like this, simply you can do this. See, I'll show you. If this profile is done, okay, let's come out. Let's try. With the simple thing, the reverse side, reverse direction, taking complete reverse. No, I think this won't be a very good idea. Okay, I'll show you the same methodology. Okay, after doing this, which material we have to remove? This material. So for removing that, we don't need to close here. We are not removing this material, but the outside material. So we need to close this profile. Okay, simply you can delete this, and now close the outside profile. That means take a line here. Okay, and yeah, take an horizontal. I'm just closing it. Okay, I'm just closing the outside profile. And what I'm doing, just remove it. And now let us control this, constrain it, say coincide, because it should be in coincidence with the axis, and then close it. Okay, we're just constraining it, nothing more than that. Okay, and now this line, I want one more line here, right? Can you see it? Still it is, still we don't have line here. So say mirror, click on this, click on this. Okay, and you can just cut it here. Okay, simply, or else you also can do one thing. You can just simply say mirror, so that we can have similar profiles on both sides. Here, just click it here, here. Okay, now check your profile is closed or not. It's closed. Okay, now because we have to remove the material here outside, so that material should be inside the profile. Okay, then simply you can go out and use that option, pocket option, to remove this material. Okay, is that clear, guys? How to, how to construct it? But one thing you can observe here, I'm not maintaining any dimensions here. Okay, I'm just saying 26, 29, Either you can maintain it or not. Yeah, that's not a big issue because you can make it T nearest, okay? Because our material is still here only. You either can maintain directly, you can take a line here, but this profile is not acceptable because this and this will be completely interfering each other. So there will be some problem while using this option. What is that? Pocket option. Okay. If you want to remove the material, there will be some problem if you exactly draw a line which is tangential to this circle. So always we have because we don't need to achieve any shape here. Okay. Even if you draw a line here, it's not something which is required for us now. Even if you want to remove this, you just need to close the profile. You just close it. That's enough. Okay. So that's the reason I've just closed it. I've taken another horizontal line and made it a little bigger profile. Okay. So that it can easily remove the material. Okay. So never create a profile like this. Don't just because see you also can create like this because our circle is up to here. So our material is only here. So why don't we just close the profile like this? We also can close the profile like this. Okay, this is also closed. We can delete here. Okay, never follow that. Okay, because later on pocket is going to give you trouble because these things here are overlapped each other. These lines are going to overlap, but this tangential, okay, this constraint is also not going to work properly. That's the reason you always need to follow this process. Is that clear? For
Yes, sir.
pockets, yeah, for pockets, please remember this. Okay, never follow such closed tangential lines, which will remove your material. It's okay to create a little bigger profile and then remove the material. Okay, so that even the next step will be easy for you, or else many errors, many things, and you'll stuck up in that. Okay, so clear, guys? Any questions on this, please? Okay, I'm coming out of this. Just save it. Good to go. Okay. Any questions? छोटा मोटा questions? कुछ भी होने दो. ఏవైనా పర్లేదు అడగండి. Questions related to Catia, related to some material things, or if you have anything in your mind, please ask me. If I have answer right now, then I'll reply you, or else in next class I'll refer and reply you. Okay, if you want to share something, happily you can share. Guys, how is the class actually? So I wanted to understand. So you guys are getting it properly? So initially,
Yes, sir.
I got a feedback from one of your friends. I'm really happy that you people are giving me feedback. Okay, because even I need to understand if my students are understanding it or not. Okay, that's very important. The interaction between you us is very important, so that I can share my knowledge and I can share my experience to you, because you people are really fresh minds. Okay, so that's always a pleasure for me to share. But at the same time, I need to understand if you people are getting it clearly. Okay, without any hesitation, you can ask me questions. And this is just beginning. Okay, as I mentioned, we have lot of big plans. Okay, so first time we are working for you people. Okay, so we have big plans to implement. So this is just starting. Once your internship is done, and then we'll look forward for other in-depth courses which will provide you knowledge on design things, which I mentioned. Okay, the difference between the CAD engineers and the designers. Okay, be a design engineer. CAD engineer is kind of just learn CATIA and you are done with that. Okay, don't stop with CATIA. Okay, your subject is very important. Your strength of materials be learn very good subject of strength of materials. Okay, how to calculate the things. Okay, all these things are very important. And as parallelly, you should be expert in software also. Okay, that I'm there to take care of that software part. And in this for this course, we are mostly working on, because only this is only for a limited period. Okay, in this limited period, we can learn only this much. Okay, that's the reason we cannot go beyond this subject. But still, I'm trying to pull you into this subject. Okay, a subject of GD&T. Okay, geometric dimensioning and tolerance. Whenever we are getting time, I'm trying to explain you why this is important. Why actually, if you start discussing on that, that will be a very big subject again. Okay, so we cannot complete it within 1 month. So that one subject will take 1 month. So that much subject is there. If you say GD&T, or if you say some other manufacturing methodologies. Okay, there are so many things, so many advanced things. So I'm just trying to give you a flavor of that. At the same time, I'm trying to give you the knowledge of CATIA, and these are the basic things. Right now, I need to equip you people with, and then going forward, I'm always there. You can contact me anytime, or you can just process. Okay, and we are always ready to support you, and we'll plan, and we'll have some sessions, this kind of sessions. Okay, so till you get a very good job, we are there. Okay, so we'll assure you. So we work with because we directly work in the industries, and also we have a lot of contacts in industries, so we know how market is right now, how much requirement is there in the market. Okay, and how much like how these design engineers are like hotcakes for these many big companies. Okay, so if you have right knowledge, then they're going to just observe you like that. Okay, they are looking for fresh minds, so that you can work on innovative projects. Okay, so many things are there, so be free, and don't consider this as your regular subject. Okay, so this is something which is a game changer. Okay, so this is don't don't just think just tomorrow. Even we used to do the same thing. If we have tomorrow exams, then sit today and just finish the syllabus, and then revise it, and then go and finish the exam. We are done. It's not like this. This is kind of after your college, or after your uh, MTech or BTech, whatever you do. Okay. After that, what you are going to do in your life. Okay. So there, practically, you can use it. Okay. And many subjects, for example, strength of material is very important for us, and um, details related to materials. Okay. All these things are very important. So you people need to understand what all things are important, and then start studying on that. Okay, I should say you people are very lucky here. In third year, no one taught me this Katia and all. After finishing my final year, I went to some place and then I learned there. For 3 months or 6 months, only 3 months I only learned Katia. I separately went there and learned Katia. Now third year itself, you people are exposed to such softwares and such advanced technology. It's really you people are really lucky people. Okay, not many are having this opportunity. Okay, so uh, make utilize of this, make use of this guidance. Okay, as I mentioned, please don't consider this as your regular subject. Okay, this is something very interesting. See how we are studying the drawings. Okay, how to get the, these are simple parts, but still we are studying it. We are going in depth and discussing and how to select this, how to do that, how to do this. Okay, this will be very interesting for you. Okay, and that's going to give you a very bright future, man. Okay, because we have seen it, we experienced it. So that's the reason it will give you opportunities to visit many countries. Okay, so to you can roam in the world, man. Many people, even I went to few countries. Okay, that's because of this design knowledge and this Katia. So just do it, man. Do it and learn it. And don't know what is planned for you. Okay, no one can say that, but where it is planned and how it is planned only depends on what kind of opportunity you are tracking. Okay, or what kind of interview you are going to crack. Okay, and if you are ready with your knowledge, and you can just get into any field. Okay, any aerospace, maybe automotive, or maybe directly you will be sitting in the NASA. I don't know. So we cannot underestimate ourselves. Okay, so there are opportunities. Sky is the limit. So that is the thing, friends. So be free and learn things happily. Okay. Okay, guys. So, any other questions on this today? If you have any questions, let me know. If everything fine, then please practice this. Okay, and then let's meet in next class with a few more questions. And if you have any queries, please come with that, and I'll